Hi guys, I hope everybody enjoyed the beautiful weather today. If you're a senior, I just want to remind you that this is your last week because we have the work assigned every day. You just have to turn in the work from this week and you are done. Fundamental Theorem of Calculus, this is what we are going to do today. We are just going to start this, so we'll do again part 1 and part 2 tomorrow. I wanted to add, and if you are a senior and you don't have anything better to do, I invite you to continue working with me. Today's lesson is going to be mostly notes, but I do want you to write them down, and that's a part of your assignment, and the assignment itself is going to be fairly short. So what we learned so far is that if the position of the object is defined with some function, then the expression for the velocity of the object is the derivative of the given function. So the derivative, see what's happened, 2 goes in front. Oh, where did my 2 go? And here's the derivative of this function. Here is that. Now, what would happen if I gave you the expression for the velocity and I would like you to find the formula from which it was obtained? Could we do this? So basically, could we undo the differentiation? And in other words, could you find the antiderivative? Okay, so today we will start with the derivative of some function and we will try to find the antiderivative. Okay, so we will try to do the same, we will try to do what we've been doing, but backwards. So notice, when you say that you are looking for the antiderivative, the notation is going to be that we are going to be looking for the function, but now if this is f of x, I am going to be looking for f of x with the capital letter. Now, what would produce, so the derivative of what function would produce 3x to the 3x squared? We need to remember what is the rule for the derivatives. So now, again, if I move my paper back to the example that I had right here, let's see what just happened. So now I'm starting with something like this. I would have to move my this number back. And then what happened here? Well, what happened here? So again, let's go back to our example. You think about this, you may want to pause just so that it makes sense for you. So if I think about the 3x squared and I want to find the derivative, I know that I would have to have this as my exponent. So I am going to write something like this. And now I go backwards and I check. Well, 3x to the power of 2, and that would be something that I have here. But my question would be, is this the only answer? Could you give me something else? Could you give me something else that would work? Well, I will give you an example. Would that work? X to the power of 3 plus 4. How about f of x? Could it be x to the 3rd power minus 15? So if we think about this, if this is my antiderivative, if I want to find the derivative, so now is this expression going to produce this? 3x squared, 4 would disappear. Well, that works. 3x squared, and this would disappear. So now think for a second, what is this number have to be? Could it be anything, or are there any restrictions? We are going to talk about this very soon. All right, let's try to do a little bit different example. This one may be a little bit more difficult because the expression itself looks like it is a little bit more tricky. However, of course we can do it. So, this is difficult to look at. So I am going to write this down in a different form. So I know that that's negative 8 times x to the power of negative 9. Remember, if it's in the denominator, it's the same that if it was the negative exponent. So I have that. And now if I want to find the antiderivative, what should have been my original exponent? Well, -8. Would that make sense if I write this as -8? I always write something if I am not sure, and then I check if I am right. So what if I say x to the power of -8? If this is my antiderivative, what happens when I go back? Well, I would say -8 and then 1. So that looks -1, and that looks that it would work. But again, is this the only answer? Can I say x to the power of 8? Well, plus 1. Could I have f of x is equal to x to the -8 plus 14? I can add any number or subtract any number, or I should ask you, could I? Again, think about this for a second. So now again, you will see in the second part what those antiderivative are used for, other than what I just said at the beginning of the lesson. I will admit, when you go to the calculus class and this concept is introduced, you will start with something a little bit different. You will look at the curves and you will see how you can find the area of the curves. Areas under the curves. And that should be an introduction. However, I kind of decided to skip it at this moment, and I will go back to this hopefully a little bit later. But we are going to get there in a little bit different way. So you just found the first two antiderivatives, basically without knowing any rules. So now, of course, there are rules for that. There are 3 of them that we are going to start with. If you are just working with the function that you have some number to the exponent, with the exponent, notice that there is a restriction that n cannot be a -1. So n has to be a rational number other than -1. Then basically, and now why -1? Why it cannot be -1? Think about this. If you add 1 to the -1, you are going to get 0 power, and then this is not going to work. So what we are going to do is we are going to take the antiderivative, and you are going to have your x. You will add 1, and then you will have n plus 1. Now we are going to add c, because as we discussed, or as we paused for a couple minutes or a couple seconds on the previous page, we decided that, well, we actually could add any number, right? Any number, because if you have that, then derivative of that, well, that disappears. So let's keep this formula in mind. You will see in a second we are going to apply it. So if it's somehow unclear at this moment, it is going to be clear in a second. Now the second rule that we are going to use is the constant multiple of power. So the same idea, but what happens if there's a number in front of that? A couple of restrictions. Again, n is a rational number, cannot be equal to -1, and k is a constant. So basically the very similar thing will happen as above, except you are going to multiply the expression by the constant k. And then the last rule, if you have a sum and difference, if antiderivatives of f of x and g of x are antiderivative of f of x and g of x respectively, then the antiderivative of the sum or difference is the sum or difference of the antiderivatives. Again, when you first look at those definitions, they may look a little bit tricky. However, when you apply them, you decide, well, that wasn't that bad. So again, copy the notes, and I am going to be looking at those formulas while working on the examples that I will give you. So here we go. The first one is f of x is equal to 4x to the power of 7. So I see that I have the my original equation, and I see that I am going to use the formula, the second formula, constant multiple. So the antiderivative, please keep in mind the notation, is going to be whatever the constant is, and that is equivalent to 4. Then I am going to have my x, and then I have the whatever the exponent is plus 1. So that is going to be 8. And then I am going to divide it by I am going to divide it by n plus 1, and n plus 1 is 7 plus 1, which is equivalent to 8. And then the very important thing is to add it at constant c, because that could be any number. Let's clean this up. 1 over 2x to the power of 8 plus c. And I very strongly want to encourage you, whenever you're working on those, please make sure you check. So now, if this is your antiderivative, if you wanted to go backwards, again, you would move the 8 in front. So 8 times half would give you 4, and you will lower the exponent from 8 to 7. Well, we did this right. All right, let's look at example number 2. Again, when you have something like this, it looks a little bit messy. So the first thing that I am going to do is I am going to write this without a fraction. So this is going to give me 2x to the power of -4. And now to find the antiderivative, I am going to apply my formula. So again, I am looking at the formula, and the formula says take the constant is 2, have your variable, and then add 1. So -4 plus 1 is going to give me -3. And then divided by n plus 1, so -4 plus 1 is -3. Again, I want you to see I am very carefully following the formula, because sometimes, especially when you have a negative exponent or any kind of fractions, it gets tricky. Always clean it up. So this is going to give me -2/3, and then x to the power of -3. Depends on what the question asks you. General idea, we don't want the negative exponent. 2/3 x to the power of 3. But again, be aware that both forms are correct. Well, we need to remember about plus c. And we need to make sure we keep it as plus c. And I should have had plus c here as well. Something that we quite often forget about, but this is very important when we are looking for the antiderivatives. All right, and then we have the last formula. So for the last formula, basically what you can do, because we have addition and subtraction, you can find the antiderivative of each piece, and then you can go from there. So for the antiderivative, I am going to have, one thing that I do want to do before we start, this is when there's no variable, we need to remember that it's the variable to the power of 0, because this is equivalent to 1. And that might be helpful to add. Notice it wasn't there, I kind of added it. So now let's start. I am going to have x to the power of 2 plus 1, which is 3. But I am also going to divide it by 3. Again, formula tells me to add 1 to this 2. Minus 8. Then I am going to do x to the power of, I will add 1 to this one that I had here, so that is going to be 2. And then I am going to divide it by 1 plus 1, which is 2. And then I am going to have 5. X to the power of 1, because I am adding 1 to the 0 that I have. And then I'm going to divide it by 1. Now, I can add c here. Now, somebody should ask or think about this, well, should I add c here and c here and c here? Would that matter? Then would I have 3c? Well, c can be any number, so it really doesn't matter. But the general idea is that we just put it at the end. Okay, and then also general idea is that we do need to clean this expression up. So the antiderivative is equivalent to, 1/3 x to the third minus 4x squared plus 5x plus c, and that is my final answer. All right, I hope you enjoyed the antiderivatives. We'll continue this tomorrow, and enjoy your practice and enjoy your day tomorrow.